Hello 9th graders! Welcome back to my virtual instruction part 2. In this video, I will guide you on how to answer activity 2 and 3. Let's start with activity 2, Gear Up. For this activity, you're going to refer in the given figure. Identify the given and answers the questions that follow. In the figure, we have two similar triangles. Triangle FTA and triangle MSI. We also have three segments which are drawn within the triangles, namely the altitudes RT and YS, the angle bisectors FH and ML, and the medians EA and IO. Let's have now the first problem. The given are the length of the angle bisectors and the length of the altitudes. Namely, if h equals 3x plus 2, ml equals 2x minus 1, rt equals 3x minus 1, and ys equals 2x minus 2. As you can see, these given segments are represented by a variable, and we are required to find the value of RT. In this problem, we can use the special segment theorem to find the value of x. But first, let us identify the triangles formed by the segments that will help us to solve this problem. The triangles that can be formed using the bisector lines FH and ML are triangle FTH and triangle MSL. While the triangles formed by the altitude lines TR and SY are triangle FTR and triangle MSY. We have now the solution. Using these triangles, we can formulate the right proportion to be used in finding the value of x. In formulating the proportion, we must remember that there must be one side that the triangles are in common in getting the three conditions. In this example, the common side between triangle FTH and triangle FTR is the side FT, while in triangle MSL and triangle MSY is the side MS. For our first condition, using triangle FTH and triangle MSL, we can formulate a proportion using its sides, with one side in common with the triangles FTR and triangle MSY. The proportion is the ratio of the angle bisectors FH and MN, which is equal to the ratio of side FT and side MS. Side FT and MS are the sides in common in the triangles. For our second condition, using triangle FTR and triangle MSY, the proportion is the ratio of the altitudes RT and YS, and which is equals to the ratio of side FT and side MS. Again, FT and MS are the sides in common. For our third condition, equate the two equations. Since both proportions have sides in common, and using substitution, the proportion that we will use is the equal ratios of the angle bisectors and altitudes FH and MN equals to RT and YS. Substituting the values, cross multiply, using the FOIL method, getting the product of the first term, product of the outer, the inner, and the last term. Likewise, on the right side of the equation, product of the first term, product of the outer, the inner term, and the product of the last term. Combine similar terms, cancelling 6x squared, adding negative 6x and 4x on the left side of the equation, while on the other side is negative 3x and negative 2x. Then the result is negative 2x minus 4 equals to negative 5x plus 1. Moving negative 5x to the left side of the equation and negative 4 to the right side of the equation. Then add, we have the result of 3x equals to 5. Divide both sides by 3, then x equals to 5/3. To get the value of RT, substitute x to its equation 3x minus 1. Cancel 3. Subtract 5 to 1. Then we have RT equals to 4. For number 2 problem, the given are the length of the medians and the altitudes. Namely, EA equals to x plus 2, IO equals to x plus 1, YS equals to 2x minus 3, and RT equals to 2x minus 2. In this problem, we will also use the special segment theorem to solve for YS. Now, let us identify the triangles again, formed by the segments that will help us to solve this problem. The triangles that can be formed using the medians EA and IO are triangle ETA and triangle ISO. While the triangles formed by the altitude lines TR and SY are triangle ETR and triangle ISY. We have now the solution. Using these triangles, we can formulate the right proportion to be used in finding the value of x. In formulating the proportion, we must remember that there must be one side that the triangles are in common, negating the three conditions. In this example, the common side between triangle ETA and triangle ETR is the side AT. While in triangle ISO and triangle ISY is the side IS. Now, for our first condition, using triangle ETA and triangle ISO, we can formulate a proportion using its sides, with one side in common with the triangles ETR and triangle ISY. The proportion is the ratio of the medians EA and IO equals to the ratio of side AT and side IS. AT and IS are the sides in common in the triangles. For our second condition, using triangle ETR and triangle ISY, the proportion is the ratio of the altitudes RT and YS, which is equals to the ratio of side AT and side IS. ET and IS are the sides in common also. For our third condition, equate the two equations. Since both proportions have sides in common, and using substitution, the proportion that we will use is the ratio of the medians EE, A, and IO equals to the ratio of the altitudes RT and YS. Substituting the values, cross-multiply, using the FOIL method, getting the product of the first term, the outer term, the inner and the last term. On the other side, we have also product of the first term, product of the second term, outer term, the inner term, and the last term. Cancel 2x squared, then add positive 2x minus 2x equals to 0. 3x and 4x equals to x minus 6 equals to negative 2. Moving negative 6 to the right side of the equation, then add negative 2 and 6, we have x equals to 4. To get the value of ys, substitute x to equation 2x minus 3, and we'll arrive to the answer ys equals to 5. Let's now proceed to activity 3. Be a judge. For this activity, we're going to read the situation. And will you read the situation, Peter? Okay. In the given situations, we have triangle log is similar to triangle fog. Therefore, the corresponding sides are proportional. Using such theorem, the proportion to be used is the ratio of side LG and side FG equals to the ratio of sides AG and sides OG. We have now the solution. By substitution, LG equals to x plus 7, FG equals to 7, AG equals to 32, OG equals to 8, then cross multiply, finding the product, combine similar terms by moving 56 to the other side, changing the sign, then subtract 224 by 56, divide both sides by 8, then we have x equals to 21. Therefore, Vanessa is right. Triangle log is similar to triangle fog when x equals to 21. That ends my video lesson. Any questions or inquiries, you can approach your grade 9 math teacher. Thank you for watching. Stay safe and God bless.